This lesson is to review how to factor the sum and the difference of two cubes. The two rules are listed on the board. The first one, how do you factor a perfect cube, subtract a perfect cube? The two factors are a binomial times a trinomial, and the factors are a subtract b, a squared plus ab plus b squared. In the second example, we are factoring the sum of two perfect cubes, and the factors are a plus b, a squared, subtract ab plus b squared. If you look at the two factors, they are exactly the same except for the first two signs. In the first rule, we have a subtract. In the original problem, notice the subtract has to be the same in the binomial. The second sign must be the opposite. Down in rule number 2, we have a plus sign in the original problem. Notice a plus in the first factor, and again the opposite sign in the second factor. And notice that the last term is always a b plus b squared. So let's try to factor a few of these. Example 1, this would be x cubed subtract 5 cubed. And so in our rule, we're going to use rule number 1. The value of a would be x, the value of b would be 5, and the factors are a subtract 5, or in this case x subtract 5, x squared, change the sign, plus 5x, and plus 25. In example 2, we are factoring the sum of two perfect cubes. So we have x cubed plus n64 is 4 cubed. Again, using rule number 2, my first factor is x plus 4. My next factor would be x squared. Change the sign, subtract 4x, and plus b squared. In this case, that would be 4 squared, or 16. In the last example, we have a little bit more difficult problem, and we are looking at the quantity 2x quantity cubed minus 3 cubed. So your a in this case would be 2x, and your b in this case would be 3. So the first factor would be 2x subtract 3. The second factor starts with a squared, and if you square 2x, you get 4x squared. Change the sign, plus the product of the two is going to be 6x, plus the b squared in this case would be plus 9. Now if you have factored them and you aren't completely sure that you have the right factors, how do you check your answer? Well, here's that number 1 problem that we did before. Let's say you were unsure it was correct. How could you check your answer? Well, we're multiplying a binomial times a trinomial. So if I multiply x times a trinomial, and then the subtract 5 times the trinomial and combine terms, I should get back to the original problem, which was x cubed minus 25. So if I take x times the trinomial, I'm going to get x cubed plus 5x squared plus 25x. If I multiply that negative 5, that subtract 5, or plus a negative 5, I'm going to get a negative 5x squared. I'm going to get a subtract 25x. I'm going to get a minus 125. If I add the like terms together, I am left with x cubed, the second term equals 0, the third term equals 0, subtract 125. So I know that I have done the problem correctly. Checking it does not take that long, probably about 20 seconds of time. The other problem that I see a lot of people have is they'll remember what the first factor is, but they have trouble remembering what the second factor is. If you remember a little bit about synthetic division or even long division, we can actually divide out the factor of x subtract 5 to be able to find out what the other factor is. If we set the denominator equal to 0, we get 5. If you remember synthetic division, that goes on the outside. I am missing both the squared and the x terms, so the coefficients of that numerator are 1, 0, 0, negative 125. If you remember your rules of synthetic division, you bring down the first number, multiply, and add. So we're going to bring down the 1, we're going to multiply by 5 and we get 5. Add 0 plus 5 and we get 5. Multiply, we get 25. Add 0 plus 25 is 25. Multiply, get 125, and a remainder of 0 because it divides evenly. The 1, 5, and 25 are your coefficients of what you get if you divide out the factor x subtract 5, and that is the remaining factor that I was missing in that original factoring problem. So again, the difference in sum of two cubes, very important concept, especially in advanced math or pre-calc and calculus.